welcome to my YouTube channel. Today I'm going to talk about kinetic or dynamic simulation. So we have been talking about how to set up the OpenPose, how to calibrate cameras, how to reconstruct 3D data, and how to simulate kinematics. And this is the last part of this YouTube series, and I will assume that you have already watched previous 4 videos, and I will directly jump into kinetic simulation. Basically, what OpenCap uses is OpenSim Moco library and automatic differentiation functions. You will have OpenSim model and kinematic data you previously extracted, and you will kind of fuse together and simulate how muscle works and what's the ground reaction force, etc. So let's jump into the Python code. So this is only the last part. So dynamic simulation, and you will need to add paths for utils dynamic simulations and OpenSim automatic differentiation paths here. So those Python code or functions are variable in the OpenCap repository. So you will just need to import or just clone the repository, and you just need to append the paths. What you really need to import is these two functions here. Once you import those functions, you need to specify the path to the model, path to the motion file, and basically path to the model and kinematic files, or a folder. Basically, you just need to specify the path right here, and in the OpenCap repository you can have several configurations, such as whether the motion is on the ground or treadmill, whether the motion is something related with squat or sit to stand or jump, or it could be other, like this. So yeah, you can specify which motion you trying to simulate with dynamic simulation functions. And in this example I did squat, so I specify the squat a motion type as a squat right here. And the trial name, that's something you gotta be careful, because this name has to be same as the motion file name here. Other than that, after configuring which motion you're trying to simulate, just plug in those variables in the past into this function, and afterward you run tracking function right here. Yeah, that's pretty much it. And if I run it, it kind of takes time to initiate all the functions ready. It's calculating or downloading the model, adjusting the muscles, etc. Processing, filtering. Okay. Now it's calculating Jacobian and how many variables you have to solve. And right now iteration is started right here. So one of the configurations you have to be careful is that time window, which is like this. I mean, if you do a squat or a sit and stand, those motions which had repetition, you just need to specify repetition like this. But if you want to simulate the motion of the walking running etc. You can specify the time window, which has to be within 2 seconds, because if you specify the time window more than 2 seconds, it will crash. I mean, uh, you will get the error of didn't converge, which means that it took like so many iterations to uh, solve the problem, and yeah, basically couldn't converge the solution. So that's something like you gotta be careful if you use time window configuration. But like for this example, I just use squat, so like I just specify the repetition, and the iteration is running. Uh, it takes quite some time if you have a lot of data. Uh, so I will just stop it because I already finished it. So once you finish the iteration, you will get like a statement saying like finish the iteration, and dynamic uh, or kinetic data is ready also. And once you have that data ready, you can just open the OpenSim, and like I showed you in the previous video, you can just upload the OpenSim model. I think I have it in the model folder like this, and you can upload the model to the OpenSim. Yep, and now it's here, and you can upload the motion file, which you can find it in Dynamics folder. So Dynamics folder is automatically created after you run the dynamic simulation code, and inside you have the folder named with the motion file name, and you open it, and this is the files, dynamic files, which was simulated from the Python code, or like OpenSim Python code. And what you can do is, for example, like you can just have the kinematic activations file, and you can associate it with the OpenSim model. You just upload it. Yep. So right now it's a squat starting point, and you can just watch it squat. And as you can see, the, the activated muscle is colored to red, depends on the degree of that activation. But this is basically the muscle simulation, like which muscle is working on during the movement. And yeah, as you can imagine, it's a squat, and this squat is a little bit distorted because of the calibration of the model. However, if you do it correctly, you will get much cleaner movement. So this is like muscle activation, and also if you want to have ground reaction force associated with the movement, you can have so you can click on associate motion data, and you can have ground reaction force resultant. This is a resultant ground reaction force along x, y, and z direction. If you want to have it separately, you can have GRF. But I will just import our resultant motion file. Okay, I think now it has it. So as you can see, there's an error uh, pointing upward. I mean, it makes sense because it's a ground reaction force, and as you can like move around, uh, you can see the ground reaction force. Again, this squat is a little bit distorted because of the calibration. However, it looks quite nice. So this is what you can do after you have 3D data from the OpenPose or like whatever pose estimator, and you can right now kind of like easily estimate the dynamics because of the OpenCap and the OpenSim software, and this has a huge possibility of Margaret's motion capture system. And yep, this is the end of this YouTube series, and thank you for watching. If you have any questions, please let me know. You can put a comment, and or you can just contact me. And yep, see you next time. Ciao.